Hi there, Algebra 2 students. Here is the key to the Unit 9 Complex Numbers test review. Question number 1 says simplify each of the following square roots in terms of I. So the first thing I'm going to do is I'm going to take a look at the prime factorization of each of these numbers. So 121 would be negative 1 times 11 times 11. There would be the prime factorization of negative 121. But we know that the square root of negative 1, this right here, square root of negative 1 is I. And then there are two 11s in there, so the square root of 121, or having the two 11s paired up in there, I can take an 11 out in front. So the square root of negative 121 is 11i. And the square root of 125, this would be negative 1 times 125 is 5 times 5 times 5. And then I do the same kind of process. The square root of negative 1, I know that, that's I. And inside the square root here are a pair of 5s. So we have a 5 outside. And left on the inside is a radical 5, so we have 5i radical 5. And for the last one, negative 90 is negative 1. 90 is 3 times 3 is 9, and then 2 times 5 is 10. So 9 times 10. Here's the prime factorization. Square root of negative 1, again, that's I. Looks like we can just take out a 3. And on the inside, I have a 2 and a 5, and 2 times 5 is 10. So the final answer is 3i radical 10. Question 2. Simplify each of the following powers of I into either 1, negative 1i, or negative I. So here's what I have to remember. This is the one thing that I remember for these types of problems, is I have to remember the first 4. I have to know that I to the first is I. I need to know that I squared is negative 1. I to the third is negative I. And I to the fourth is 1. If you know those 4, the rest of this will be really, really easy. Because what I'm going to do is I'm going to take the power and I am going to divide it by 4. And I'll do this for every one of these. And whatever the remainder is, if the remainder is 0.25, then that means there is a remainder of 1. So that means it is the same as I to the first. If you have a remainder of 0.50, that is like 2/4. So it is like I squared. If it's 0.75, it would be just like having 3/4. So it would be just like I to the third. And if I divide by 4 and it comes out even, then it's going to be just like I to the fourth. So the first 3 are pretty straightforward and pretty easy. They're 3 of the 4 that I have memorized. So I squared is equal to negative 1. I to the third is negative I. And I to the fourth is 1. So next one, to do 31. I'm going to do 31 and I'm going to divide it by 4. So 31 divided by 4. My answer is 7.75. 0.75 is 3/4. So I to the 31 is just like I to the 3. So this is the same as I to the 3. which is negative I. If I do 44 divided by 4, you'll see that it is 11. No remainder. So if there's no remainder, then it is the same thing as I to the 4th, which is 1. Let's do 9 divided by 4 for F. That is 2.25. 0.25 is 1/4. So I to the 9 is the same as I to the 1, which is just I. Okay. 38 is the next one. 38 divided by 4 is 0.5. 0.5 is just like 2/4. So this is the same as I to the 2. And I to the 2 is negative 1. And the last one is 83. 0.75. That is 3/4. So this is the same as I to the 3. And I to the 3 is negative I. All right, question 3. Part A and B, I guess, solve each of the following incomplete quadratics. Leave your answer in simplest radical form. So in order to solve this, I'm going to try to get x squared by itself first. So I'll subtract 20. So 3x squared equals negative 48. I'll divide both sides by 3. And that is negative 18. And then square root, so x equals, I'm putting in the square root, so positive negative, square root of negative 18. And then I have to simplify that. Negative 18 is, so plus or minus, is 9 times 2. 9 times 2 is 18. So the square root of 9 is 3. It is negative, so it's 3i. And we said it was 9 times 2. If you're wondering how I'm reducing this fraction down, go ahead and take a look at question number 1, and you can expand that and do that in the long expanded version if you need to. For part B, I'm going to again solve for x squared, so let's start by multiplying by 2. And the second step will be add 2 to both sides. And then square root. Again, I'm putting in the square root, so a positive or negative. Square root of negative 12. And then simplify this. 12 is 4 times 3. So the square root of 4 is 2. I, because of its negative. And I said it was 4 times 3, so inside the radical, it's 3. Question number 4. Find each of the following sums and differences. Sums and differences, this means just add them together or subtract them. So I'm going to combine like terms. I have 8 plus negative 2. 8 plus negative 2 is the same thing as 8 minus 2, which is 6. And I have 6i plus negative 3i, which is the same thing as 6i minus 3i, which is 3i. Now part B is subtraction, and you'll notice I'm subtracting a quantity, so I'm actually going to distribute the negative sign. And this may help some of you see this a little bit better. If I distribute this negative sign, my first term is still 3 plus 4i. Distribute the negative sign means that would make that a negative 10, and negative 2i would become a positive 2i. And now I'll combine like terms. Let's do my real stuff first. 3 and negative 10. 3 minus 10 is negative 7. And then 4i plus 2i is 6i. So negative 7 plus 6i. Number 5 does not have a plus or minus between the parentheses. So this means I have to FOIL. I am going to FOIL question 5. So 3 times 4 is 12. 3 times 2i is 6i. 7i times 4 is 28i. And 7i times 2i is 14i squared. Now I know from earlier in this review that I squared is actually equal to negative 1. So this is actually 12 plus 6i plus 28i plus 14 times negative 1. 14 times negative 1 is negative 14. So this is actually minus 14. And now I'll combine like terms. 12 and negative 14. 12 minus 14 is negative 2. And then my i's, 6i and 28i is 34i. So negative 2 plus 34i. For part B, again, let's FOIL. So I FOIL it together first. Now I see the I squared. I squared is negative 1, so let's show this. Negative 3 plus 5i plus 12i. And negative 20 times negative 1. Negative 20 times negative 1 is positive 20. Now combine like terms. Negative 3 and positive 20 is 17. 5i and 12i is 17i. So 17 plus 17i. And that concludes page 1. Page 2, question number 6 says state the complex conjugate of 6 plus 13i. Complex conjugate just means take this middle sign and change it from positive to negative or negative to positive. So instead of 6 plus 13i, this will be 6 minus 13i. That is the complex conjugate. It is as simple as that. Number 7 says find the product, which means multiply, of negative 5 plus 2i and its complex conjugate. So I have negative 5 plus 2i, and product means multiply, and its complex conjugate would be negative 5 minus 2i. Now I'll FOIL. That is negative 5 and negative 5 is 25. Minus 10i. Plus 10i. That's negative 5 times negative 2 is positive 10. The middle, 2i times negative 5 is negative 10i. And 2i times negative 2i is negative 4i squared. The nice thing about multiplying with a complex conjugate is those middle terms will always cancel. You'll see 10i minus 10i, that's 0. Negative 4 times I squared is the same thing as positive 4. So that is 25. Negative 4i squared would be positive 4. Negative 4 times negative 1 is positive 4. And 25 plus 4 is 29. You'll notice that anytime you multiply complex conjugates, you will always get a real number answer. Number 8, perform the following complex calculation. Okay, so I'm going to do this in 2 separate parts. I'm going to do the 2 plus 3i quantity squared. So 2 plus 3i times 2 plus 3i. That is quantity squared. So let's FOIL. 2 times 2 is 4 plus 6i. 3i times 2 is another 6i plus 9i squared. Remember that 9i squared, I squared is -1, so 9 times -1. This last term is actually minus 9. So I'm just going to change that, minus 9. And then combine like terms. So 4 minus 9 is -5. 6i plus 6i is 12i. So that's my left side. So this left part is -5 plus 12i. Now on the other side, I have -4 times 3 plus 7i. And I just distribute this side. So -4 times 3 is -12 minus 28i. -12 minus 28i. And now I'll combine like terms. -5 and -12 is -17. And 12i minus 28i would be -16i for my final answer. Number 9 says solve each of the following quadratic equations using the quadratic formula. So I've given you the quadratic formula. First thing I do is just make sure it's equal to 0, which a is. So I'm going to find a, b, and c. So a is the number in front of x squared, it's 1. B is -10, and C is 34. So the opposite of B would be 10. Plus or minus. B squared is 100 minus 4 times 1 times 34. 4 times 1 times 34 is 136. All divided by 2 times a, which is 2. Okay, so I have 10 plus or minus the square root of 100 minus 136 is -36, all over 2. The square root of -36, square root of 36 is 6, and it's negative, so it's 6i, all over 2. And then I simplify the fraction. Everything's divisible by 2, so 10 divided by 2 is 5, plus or minus 6i divided by 2 is 3i. So 5 plus or minus 3i. For b, I have to first get it set equal to 0. So I have to subtract 3x on both sides. I have to add 1 on both sides. I have x squared plus 4x plus 5. And I'll define a, b, and c. A is 1, b is 4, c is 5. So here's the quadratic formula, the opposite of b, -4, plus or minus the square root of b squared, 16. Minus 4 times 1 times 5 is 20. All divided by 2 times a. 2 times 1 is 2. 16 minus 20 is -4. So I have -4 plus or minus the square root of -4. Square root of -4. Square root of 4 is 2. So square root of -4 is 2i all over 2. And then divide everything by 2. -4 divided by 2 is -2. 2i divided by 2 is 1i. So negative 2 plus or minus I. To question 10. Determine the number and nature of the roots of each of the following quadratics. Do this by first calculating the discriminant. So remember, the discriminant is just b squared minus 4ac. If, and I'll build a little table down here. So I'm going to do b squared minus 4ac. And I'm going to get an answer. If this answer is a positive number, there are two real roots. If this is 0, there is one real root. And if it is a negative number, there are two imaginary roots. So this is what I'm going to look at. I'm going to do b squared minus 4ac for each one of these, and I'll just check and see what type of a number it gives me. So in part A, b squared, that is 5 squared, which is 25, minus 4 times 1 times 2. 4 times 1 is 4, times 2 is 8, and 25 minus 8 is 17. Because 17 is a positive number, there are two real roots. For b squared, negative 3 squared is 9 minus 4 times 9 times 2. Well, 4 times 9 is 36 times 2 is 72. And 9 minus 72 is negative 63. So the discriminant is negative, which means there are two imaginary roots. For c, b squared, 6 squared is 36, minus 4 times 9 times 1. 4 times 9 is 36. 36 minus 36 is 0. It's 0, so there is one real root. And you may actually see on the key, it says that there are two equal rational roots, or one double root. That one real root is called a double root anytime the discriminant equals 0. Let's take a look at D. We have to do b squared, so negative 1 squared is 1, minus 4 times a times c. 4 times negative 2 is negative 8, times negative 1 is positive 8. 1 plus 8 is 9. I'm sorry. b squared, negative 1 squared is 1, minus 4. Negative 4 times negative 2 is positive 8, times negative 1 is minus 8. So that should be 1 minus 8, which is negative 7. The discriminant there is negative 7. So because it's negative, there are two imaginary. E, b squared, 9 squared is 81, minus 4 times 7 times 2. 4 times 7 is 28, times 2 is 56. And 81 minus 56 is 25. It is a positive number. Two real roots. The last one, b squared, 3 squared is 9. Minus 4 times 1 times 6, 4 times 1 times 6, 4 times 1 is 4, and 4 times 6 is 24. 9 minus 24 is negative 15. It is negative, so 2 and imaginary roots. Now, we talked a little bit about whether they were rational or not. So if you want to know the real roots, whether the real roots are rational, just ask yourself if the discriminant is a perfect square. So as I look at these, 17 is not a perfect square, so those two roots are irrational. Negative 63 is imaginary. 0 is a different case. That's one real. Negative 7 is imaginary. 25 is a perfect square. So those two real roots would both be rational. And then negative 15 is also imaginary. So if you needed to know a little bit more about those real roots, whether they are rational or not, you could take a look and see if you have some perfect squares. That concludes page 2. The final page. Here's a multiple choice question, number 11. For which discriminant is the following graph possible? So I can see that this graph has two roots. It has two real roots. It actually touches the x-axis. So that means that the two real roots means that the discriminant must be a positive number. So part A says the b squared minus 4ac, the discriminant is a negative number. We know that's not true. B squared minus 4ac equals 0. That's not true. That would mean that there's one root. So my answer here is C. It must be some positive number. Number 12 is also multiple choice. It wants us to use the quadratic formula. So the quadratic formula will say b squared minus 4ac. So the opposite of b, so opposite of 6 is negative 6, plus or minus the square root. But I'm going to do this one in the calculator. B squared, so 6 squared, minus 4 times the a, which is 1, times the c, which is 18, gives me negative 36. All divided by 2a. 2 times 1 is 2. Square root of negative 36 is 6i. So negative 6 plus or minus 6i all over 2. And then divide by 2. Negative 6 divided by 2 is negative 3. So I can throw this one and this one out. And then 6i divided by 2 is 3i. So my answer is D, negative 3 plus or minus 3i. Question 13 is another multiple choice. Which of the following quadratics is the discriminant equal to 0? So this means equal to 0, I have one real root. So where does this, which parabola touches the x-axis in one spot? So A, it does not touch the x-axis at all. That would be imaginary, two imaginary roots. B, it touches one time at 2. That would give me one real root. C, touches in 2 spots. That would give me 2 real roots. And D, touches in 2 spots. That would give me 2 real roots. So my answer is B. And question 14, making sure that we still remember how to factor. I'm going to have to do, for the first one, A times C is the key. 3 times negative 10 is negative 30. So that's 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6. It is negative, so the big number takes the negative sign. And which pair would add up to negative 13? 2 minus 15 is negative 13. So I'm going to use the airplane method here. 3x squared tells me that I have 3x in front of both. And then I have a positive 2 and a negative 15. And the step to the airplane method is I have to make sure that one of these quantities is not divisible. So 3 and 2, there's nothing divisible about 3 and 2. So 3x plus 2 is one of my roots. And the other, 3x minus 15, these are both divisible by 3. So 3x divided by 3 is x, and negative 15 divided by 3 is negative 5. So my factored form, 3x plus 2 times x minus 5. B, there are 4 terms, so I'm going to do factor by grouping. I'll group these together. 16x cubed and negative 8x squared, they have a GCF of 8x squared. When I factor out an 8x squared, I would get 2x minus 1 from that first group. Second group, 6x minus 3, they both have there is a GCF of 3 there. So if I factor out a 3, I would get 2x and minus 1 as well. So I'm looking at my 2 GCF expressions. They both have a 2x minus 1, so that's one of my 2 factors. So 2x minus 1 is one factor. And the other factor is what is out in front of both of those two. So 8x squared and a positive 3. So my factored form is 2x minus 1 and 8x squared plus 3. And C, there are 2 terms. So this is one of my special cases. This is the difference of 2 perfect squares. The square root of the first term, square root of 144x squared is 12x. And the square root of the last term, the square root of 9y squared is 3y. One gets a plus, one gets a minus. So the factored form of C is 12x plus 3y and 12x minus 3y. I hope that you find this video useful and happy studying.